Hi, myself Mrs. Satabdi Dhar, and in this video I am going to discuss with you about what is process management in operating system. From unit 3, of which the name is process management, I am going to discuss about what is processes, the states of processes, and process control block. Next, we will come on process scheduling, scheduling queues, scheduler and context switching, and operations on processes.
Now, to know about what is process management, first we have to know what is process. A process is mainly a program in execution where the execution of a process must progress in sequential order or based on some priority or algorithms. In other words, it is an entity that represents the fundamental working that has been assigned to a system. Then, when a program gets loaded into the memory, it is said to as a process. This processing can be categorized into four sections. These are heap, data, stack, and text. The resources that a process required for its execution is called process component. What? Process component. There is also a state that is associated with a process at a particular instant of time called process state. Similar to these concepts, there are a number of concepts associated with the process management function of an operating system. Some of those concepts are given as follows, like process state, process control block, that is PCB, process operations, process scheduling, process synchronization, inter-process communication, and deadlock. Now, as I have told you before that process memory is divided into four sections, and you also can see in this picture the sections are text section, stack, data section, heap section. The text section comprises the compiled program code read in from non-volatile storage when the program is launched. The data section stores global and static variables allocated and initialized prior to executing main. The heap is used for dynamic memory allocation and is managed via calls to new, delete, malloc, free function, etc. And the stack is used for local variables. Space on the stack is reserved for local variables when they are declared at function entrance or elsewhere, depending on the language. And the space is freed up when the variables go out of scope. Note that the stack is also used for function return values, and the exact mechanism of stack management may be language specific. Also note that the stack and the heap start at opposite ends of the process free space and grow towards each other. If they should ever meet, then either a stack overflow error will occur or else a call to new or malloc will fail due to insufficient memory available. When processes were swapped out of memory and later restored, additional information must also be stored and restored. Key among them are the program counter and the value of all program registers. Now, here comes what is process management. Process managements involve the execution of various tasks such as creation of processes, scheduling of processes, management of deadlock, and termination of processes. It is responsibility of operating system to manage all the running processes of the system. Operating system manages processes by performing tasks such as resource allocation and process scheduling. When a process runs on computer device memory and CPU of computers are utilized, the operating system also has to synchronize the different processes of computer system.
Now we will know that what are the process states. A process state can be defined as the condition of processes at the particular instant of time. Process state defines the current position of process. This helps to get detail of our process at the particular instant. There are basically 7 states of process in operating system. The following are the 7 states of the process. Those are new, ready, waiting, executing, blocked, suspended, and terminated. Now, what is new? When any program is calls from secondary memory or calls from hard disk to primary memory or RAM, then the new process is created. Basically, it specified the time when a process is created. The next one is ready. In this time interval, the state of the process is loaded into the primary memory and ready for execution. The next state is waiting. In this state, the process is kept on hold and other processes are allowed to start other execution. In other words, it specifies the time interval when a process waits for the allocation of CPU time and the other resources for its execution. The next state is executing. This is the main state of any process. In the state, the process is executing. In other words, it is the time interval when a process is being executed by the CPU. The next state is blocked. It specifies the time interval when a process is waiting for an event like input or output operations to complete. The next one is suspended. It specifies the time when a process is ready for execution but has not been placed in the ready queue by operating system. And the last one is terminated. It specifies the time when a process is terminated or ended and all the resources that are utilized by process and memory that is utilized by the process are free. In this picture, you can see all the 7 states of process. Now, when a process executes, it passes through different states, which is known as process life cycle. These stages may differ in different operating systems, and the names of these states are also not standardized. In general, a process can have one of the following 5 states at the time. In the above image, you can see that when a process is created, then it goes into the new state. After the new state, it goes into the ready state. If the ready queue is full, then the process will be shifted to the ready suspended state. From the ready state, the CPU will choose the process and the process will be executed by the CPU and will be in the running state. During the execution of the process may need some input output operation to perform. So it has to go into the waiting state, and if the waiting state is full, then it will be sent to the waiting suspended state. From the waiting state, the process can go to the ready state after performing input-output operations. From the waiting suspended state, the process can go to waiting or ready suspended state. At last, after the complete execution of the process will go to the terminated state and the information of the process will be deleted. This is the whole life cycle of a process. The next topic is process control block. Process control block is a data structure which is associated with any process and provides all the complete information about the process. The process control block is the manifestation of a process in an operating system. Process control block is important in multiprogramming environment as it captures the information pertaining to the number of processes running simultaneously. Now, what is the role of process control block? The role or work of process control block or PCB is process management is that it can access or modified by most operating system utilities including those are involved with memory scheduling and input-output resource access. It can be said that the set of process control blocks give the information of the current state of the operating system. Data structuring for processes is often done in terms of process control blocks. For example, pointers to other process control blocks inside any process control blocks allows the creation of those queues of processes in various scheduling states. Now, the following are the various information that is contained by process control block. Naming the process, state of the process, resources allocated to the process, memory allocated to the process, scheduling information, input-output devices associated with process. Now, through this picture, you can understand the components of process control block. The process control block's components are process ID, process state, program counter, register information, scheduling information, memory related information, accounting information, status information related to input output. Now the first one is process ID. In computer system, there are various processes running simultaneously and each process has its unique ID. This ID helps system in scheduling the processes. This ID is provided by the process control block. In other words, it is an identification number that uniquely identifies the processes of computer system. The next one is process state. As we know that the process state of many processes can be new, running, waiting, executing, blocked, suspended, and terminated. Process control block is used to define the process state of any process. In other words, process control block refers the state of the processes. The next one is program counter. Program counter is used to point to the address of the next instruction to be executed in any process. This is also managed by the process control block. Next one is register information. This information is comprising with the various registers such as index and stack that are associated with the process. This information is also managed by the process control block. The next one is Scheduling information. Scheduling information is used to set the priority of different processes. This is very useful information which is set by the process control block. In computer system, there were many processes running simultaneously and each process has its priority. The priority of the primary feature of RAM is higher than other secondary features. Scheduling information is very useful in managing any computer system. The next one is memory related information. This section of the process control block comprises of page and segment tables. It also stores the data contained in base and limit registers. The next one is accounting information. This section of process control block stores the details related to central processing unit, utilization and execution time of a process. The last one is status information related to input and output. This section of process control block stores the details pertaining to resource utilization and file opened during the process execution. The operating system maintains a table called process table, which stores the process control block related to all the processes. The next topic is process scheduling. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the strategy selection of another process on the basis of the particular strategy. Process scheduling is an essential part of a multiprogramming operating system. Such operating systems allow more than one process to be loaded into the executable memory at the time, and the loaded process shares the CPU using time multiplexing. Scheduling fell into one of the two general categories. When the currently executing process gives up the CPU voluntarily, it's known as non-preemptive scheduling. And when the operating system decides to favor another process, preempting the currently executing process is known as preemptive scheduling. Now, what is process scheduling queues? The operating system maintains all PCBs in process scheduling queues. The operating system maintains a separate queue for each of the process states, and PCBs of all processes in the same execution state are placed in the same queue. When the state of the process is changed, its PCB is unlocked from its current queue and moved to its new state queue.
The operating system maintains the following important process scheduling queues. The first one is job queue. This queue keeps all the processes in the system. The next queue is ready queue. This queue keeps a set of all processes residing in main memory ready and waiting to execute. A new process is always put in this queue. And the next one is device queues. The processes which are blocked due to unavailability of an input-output device constitute this queue. Now, as shown in this diagram, there represents rectangle, circle, arrows as you can see. Rectangle represents a queue, circle denotes the resource, arrow indicates the follow of the process. Every new process first put in the ready queue It waits in the ready queue until it is finally processed for execution. Here, the new process is put in the ready queue and wait until it is selected for execution or it is dispatched. One of the processes is allocated the CPU and it is executing. The processor should issue an input-output request. Then it should be placed in the input-output queue. The process should create a new sub-process. The process should be waiting for its termination. It should remove forcefully from the CPU as a result interrupt. Once interrupt is completed, it should be sent back to ready queue.
The two-state process model refers to running and non-running states. Now, what is the running and this not running state? When a new process is created, it enters into the system as in the running state, as you can see in this picture. And not running state, processes that are not running are kept in queue, waiting for their turn to execute. Each entry in the queue is a pointer to a particular process. Queue is implemented by using linked list. Use of dispatcher is as follows. When a process is interrupted, that process is transferred in the waiting queue. If the process has completed or aborted, the process is discarded. In either case, the dispatcher then selects a process from the queue to execute. Now, what is the scheduling objectives? What are the scheduling objectives? Here are important objectives of process scheduling. Maximize the number of interactive users within acceptable response times. Achieve a balance between response and utilization. Avoid indefinite postponement and enforce priorities. It also schedule It also should give reference to the processes holding the queue resources. Now, what are schedulers? Schedulers are special system software which handle process scheduling in various ways. Their main task is to select the jobs to be submitted into the system and to decide which process to run. There are three types of scheduler: long-term scheduler, short-term scheduler, and medium-term scheduler. Now here I am discussing about what is short-term scheduler. Short-term scheduler is also called as CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria. It is a change of ready state to running state of the process. CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. Short-term scheduler, also known as dispatchers, make the decision of which process to execute next. It is faster than the long-term scheduler. Next, I am going to discuss about long-term scheduler. Long-term scheduler is also called a job scheduler. A long-term scheduler determines which programs are admitted to the system for processing. It selects processes from the queue and loads them into memory for execution. Process loads into a memory for CPU scheduling. The primary objective of the job scheduler is to provide a balanced mix of jobs, such as input-output bound and processor bound. It also controls the degree of multiprogramming. If the degree of multiprogramming is stable, then the average rate of process creation must be equal to the average departure rate of processes leaving the system. On some systems, the long-term scheduler may not be available or minimal. Time-sharing operating systems have no long-term scheduler. When a process changes the state from new to ready, then there is use of long-term scheduler. The next one is medium-term scheduler. Medium-term scheduling is a part of swapping. It removes the processes from the memory. It reduces the degree of multiprogramming. The medium-term scheduler is in charge of handling the swapped out processes. A running process may become suspended if it makes an input-output request. A suspended process cannot make any progress towards completion. In this condition, to remove the process from memory and make space for other processes, the suspended process is moved to the secondary storage. This process is called swapping, and the process is said to be swapped out or rolled out. Swapping may be necessary to improve the process mix. Now here is the difference between those schedulers. Now for long-term scheduler, it's a job scheduler, and the short-term scheduler is known as CPU scheduler, and the medium-term scheduler is process swapping scheduler. For long-term scheduler, speed is lesser than short-term scheduler, whereas speed is first state among the two, that is long-term scheduler and medium-term scheduler. In medium-term scheduler, is in between both short and long-term scheduler. In long-term scheduler, it controls the degree of multiprogramming, whereas short-term scheduler provides lesser control over degree of multiprogramming. And for medium-term scheduler, it reduces the degree of multiprogramming. For long-term scheduler, it is almost absent or minimal in time-sharing system. And for short-term scheduler, it is also minimal in the time-sharing system. And for medium-term scheduler, it is a part of time-sharing systems. For long-term scheduler, it selects processes from pool and loads them into memory for execution. For short-term scheduler, it selects those processes which are ready to execute. And for medium-term scheduler, it can reintroduce the process into memory and execution can be continued. Now the next topic is context switch. A context switch is the mechanism to store and restore the state or context of a CPU in process control block or PCB so that a process execution can be resumed from the same point at a later time. Using this technique, a context switcher enables multiple processes to share a single CPU. Context switching is an essential part of a multitasking operating system features. When the scheduler switches the CPU from executing one process to execute another, the state from the current running process is stored into the process control block. After this, the state for the process to run next is loaded from its own PCB and used to set the PC registers, etc. At the point, the second process can start executing. Context switches are computationally intensive since register and memory state must be saved and restored. To avoid the amount of context switching time, some hardware systems employ two or more sets of processor registers. When the process is switched, the following information is stored for later use, like program counter, scheduling information, base and limit register value, currently used register, changed state, input output state information, and accounting information. Now, what are the operations on processes? There are many operations that can be performed on processes. Some of these are process creation, process preemption, process blocking, and process terminations. These are given in details as follows. The first one is process creation. Processes need to be created in the system for different operations. This can be done by the following events like user request for process creation, system initialization, or execution of a process creation system call by a running process, or batch job initialization. A process may be created by another process using fork. As you can see in this picture, the creating process is called the parent process and the created process is the child process. A child process can have only one parent, but a parent process may have many children. Both the parent and child processes have the same memory image, open files, and environment strings. However, they have distinct address spaces. A diagram that demonstrates process creating using fork is as follows. The next one is process preemption. An interrupt mechanism is used in preemption that suspends the process executing currently, and the next process to execute is determined by the short-term scheduler. Preemption makes sure that all processes get some CPU time for execution. A diagram that demonstrates process preemption is as follows. The next one is process blocking. The process is blocked if it is waiting for some event to occur. This event may be input output, as the input output events are executed in the main memory and don't require the processor. After the event is complete, the process again goes to the ready state, as you can see in this picture. And the last one is process termination. A process terminated if when a process completes its execution. Also, these events like OS, hardware interrupt, and software. A child process can be terminated by its parent process if its task is no longer relevant. The child process sends its status information to the parent process before it terminates. Also, when a parent process is terminated, its child processes are terminated as well, as the child process cannot run if the parent process are terminated. Hope through this video I can make you understand about some topics like process states and its life cycle, process control block, process scheduling, and the different types of operations on process. Thank you for watching this video. In my upcoming video, I will discuss about inter-process communication, semaphores, threads, and the different types of multi-threading models. Don't forget to subscribe my channel, and to get updates definitely press the bell icon. Thank you.